Hello everyone, and thank you for joining today's live training. My name is Reese and I'm going to be your moderator for today's session. We're going to kick off in a few minutes. We're just waiting so everyone has a chance to join. In the meanwhile though, we'd love to hear from you. So let us know where you're joining from using the comments or the chat, depending on where you're watching from. And yeah, maybe tell us something that you'd like to get out of today's webinar. For today's live training, we will be having a code along, and we will need you to download Miniconda and Visual Studio Code. I will be posting links to the download links of both of those shortly, so please keep your eyes peeled for those and yeah, have them installed and ready to go for the code along. We'll be running through some slides beforehand, so there is some time to get those bits installed, but yeah, please make sure you've got them if you want to join in on the live training. I'll be back in a short while to repeat these messages for any new joiners, but until then, enjoy the background music. Hello everyone, and thank you for joining today's live training. My name is Risa and I'll be your moderator for today's session. We're going to kick off in about 30 seconds or so. We've just been waiting so everyone has a chance to join. If you haven't already, let us know where you're joining from and what you'd like to get out of today's session. And just to note as well that we will have a live code along with the session today. So we'll need you to download Miniconda and Visual Studio Code as well. So please have those installed in the next 10 minutes or so that you can join in with the live code log. And I think with that, I will hand you over to your host for today's session, Richie. Richie, please take it away.
Hi there, data scamps and data champs. This is Richie. So today we're talking about responsible AI. And there have been a lot of dramatic claims recently about artificial intelligence murdering us all. But the immediate problems are much more pedestrian. So the most common problem with AI is simply that it performs poorly in some situations and gives you bad predictions or bad recommendations. And depending on what you're doing with your model, this can be unfair to your customers, or it could be unfair to parts of society, or just generally cause problems. And that means it's your responsibility as a data scientist or as a machine learning scientist to evaluate the performance of your models and look out for bias and see how fair it is. And so I need to warn you that today's session might get a little bit messy technically, just to begin with. So you're going to be using the Microsoft Responsible AI Toolkit. And as Reese mentioned, there's a Python package which creates an interactive dashboard. Now, unfortunately, that feature is not yet supported on DataCamp Workspace. So rather than using Workspace today, we're going to recommend that you either run Jupyter Lab locally, or you run VS Code locally and use the Jupyter notebook within VS Code. So we're going to show you how to do this. If you don't want to do it live, that's totally fine. Just watch and see what's happening. The most important thing today is you understand how to evaluate your machine learning models. So I would say worry less about the code today and more about understanding how to evaluate your models. So if you want to just watch today, follow along on the recording, that's totally fine as well. Now, with that out of the way, I'd like to introduce our guest. So Ruth Yakubu is a principal cloud advocate at Microsoft, and Ruth's an expert in data and analytics, cloud data platforms, and responsible AI. And she's on a mission to bring awareness on tools available to debug machine learning models to be less harmful and expose responsible AI issues. So she really is the right person to be talking to us today. So with that, I'm going to be quiet and over to you, Ruth.
Thanks a lot, Richie. Your introduction kind of scared me there. Responsible AI is important, but yeah, telling people it's going to murder us, that's on another level. But kind of like Richie mentioned, it is a very important topic. especially with the new advances and breakthroughs in AI. We are hearing a lot of chatter almost from everybody. And there's a lot of people requesting for there to be some kind of regulations around AI. So in today's session, we're going to talk about how to evaluate machine learning models in Python so they can adhere to the responsible AI principles. So to begin with, let's go through some high-level overview of what responsible AI is. We hear that terminology, so let's have a level set of what that is. Then we'll go into some of the areas that are key in terms of what the dashboard is trying to solve and mitigate. So once we're navigating through the dashboard, you understand exactly what the issue is, the traditional issues or blind spot that we usually run into, and what the dashboard is solving. Richie already introduced me, so we don't need to go into that. But my name is Ruth Yakubu, and I'm a cloud advocate at Microsoft. And I am absolutely excited to be talking to you guys this morning or this afternoon, depending on where you are in the world. So to get started, the question is, what is responsible AI? We hear ethical AI, we hear responsible AI. But for us at Microsoft, when we refer to the term responsible AI, the areas that we're looking at is fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. So as we create our machine learning models, one of the things we need to do is pause to figure out, okay, is my AI system violating some of these issues? So that's what we mean when we're talking about responsible AI. The next thing is traditionally, when we're building our models, we have several ways of after a model is built, several metrics that we'll look at. Let's say it's a classification use case, we'll look at the accuracy, we'll look at things like recall to figure out, okay, is my model accurate? If it's a regression type of use case, we may look at the absolute mean square, those type of metrics. So all of these are calculation based when we're trying to evaluate the performance of the model. So going back to the prior slides that we have, if you have a model and you're evaluating whether it's good to go out the door, the question is, with the metrics that we currently use, or traditional metrics, which part actually points out and tells us like, yep, this is an inclusive, my model is really checks off when it comes to inclusivity, or it checks off when it comes to privacy and people's security or fairness. And a lot of industries are being regulated right now. So let's say if your application deals with financial services or the healthcare, how do you provide transparency? That sort of thing. Yes, we have Lime, we have SHAP, but some of these solutions out there are not very easy to utilize and understand. So what the industry has been doing, since this is a gap and a struggle in the data science and machine learning community, yes, it's not like we do disagree that responsible AI is not important, everybody, for the most part, I hope, understands that, yes, this is an issue. But at the end of the day, you as a machine learning specialist or AI developer, you're trying to figure out, okay, what tools are out there for me to mitigate my model? How do I prove that I actually went through and my model is less harmful and more trustworthy? So, what a lot of some of the organizations, for example, Fair, Learn, Interpret, ML, out there have done is they've created open source solutions to help end users uncover some of the problems. In addition, there has been a lot of strides in academics in terms of contributing to some of the tools that can help data scientists be able to uncover issues that can be in their machine learning models. And also at Microsoft, researchers worldwide are constantly tackling with this. So Microsoft has also come up with several open source solutions to help data scientists mitigate this issue. Problem is, for each solution, there's probably a library out there that you probably need to install. You do all the analysis, but it only resolves one problem. You need to bring in another library to do another analysis. And some of the investigation that you're doing, some of them correlate with each other, but the problem is everything is so disjointed. It's hard to really figure out, get a holistic understanding of your model's health. So what Microsoft has done is introduce something called the Responsible AI Dashboard. This solution is available in the Azure Machine Learning Studio. But the awesome and exciting thing is to share with you guys is there's also a free open source version of it that is available to everybody. So some of the components that are available, which we'll go into more details shortly, is error analysis, data exploration, model overview, fairness assessment, model interpretability and explainability, counterfactuals. We'll also get into that. These are the useful tools that help expose some of the responsible AI issues that you have. Also for decision makers, a lot of decision makers make their decisions based on the data that we have. So one of the problems is if, like, how can you help decision makers make decisions a little more with confidence, knowing that the model they're dealing with is fair, that sort of thing. So with decision makers, developers, or data scientists can work very closely with decision makers with the causal analysis and the counterfactual modules. So all of these sections that I mentioned are the different modules that are within this holistic, nice interactive dashboard that we're going to be exploring today. So one of the issues that we face is a common thing is trying to figure out where errors we have, model errors, how to identify model errors. When I talk about model errors, I mean, okay, you have a model, it's probably doing predictions. Which are the areas where the model did not make an accurate prediction? Where is the model erroneous? Like, which demographics is the model being erroneous? So in most cases, what we're used to is we'll see an accuracy, which is actually an aggregated accuracy score that we get from maybe after weeks or months of trying to fine tune and train our model. And the accuracy score may come up to be 89%, which is good. And we're excited, and it's probably good enough, depending on the use case, to be shipped out into production. But one of the hidden areas that we don't know is there could be certain demographics that the model is only accurate 42% of the time. And for this could be an even critical demographic for your use case or for your product that you're shipping out. So this is areas that we need to be mindful when we're debugging to figure out, okay, what are the demographics that are negatively going to be impacted by this model. So that's where we have error analysis. The next part is we come into areas where the data distribution is either overrepresented or underrepresented. If it's overrepresented, the model will probably favor the overrepresented population. And if it's underrepresented, the model is probably not going to favor that. And it's probably not going to learn well, and there could be biases. And there are some cases where you don't even have a representation in your data set. So these are areas where biases start creeping in. The next thing that we're aware of, yes, we have a model we train. We're highly confident in it, but one of the questions that is out there is understanding the behavior of a model. Model is usually a black box to us. So when it makes an outcome or prediction, the question is, how do we figure out what drove the model's prediction? When it makes a mistake, especially if you're going to be audited, how do you prove or bring transparency to show that these are decisions, these are the features that the model utilized to make this type of prediction, good or bad? So making this more like a glass box is what we're striving for. And yeah, we'll get to the references later. So the very first thing we're going to do is get into the code to figure out how you can replicate actually training your model, and how do you train your model, and how do you get it into the Responsible AI dashboard. So the very first thing is, I know we shared the dashboard. I mean, we shared the link for you to download the Miniconda, and also where to download the VS Code, because in this demo today, I'm going to be utilizing VS Code. The good thing about VS Code is it's free. So you can easily run notebooks, your Python notebooks in there. If you also have a Jupyter Notebook, you can totally run the notebook. So one of the things that you can do is clone, go ahead and clone the repository. So once you clone the repository, you have it in the drive. The very first thing you need to do is follow the link that Reese shared earlier, And basically, you can download Miniconda. Miniconda is a little lightweight, or Anaconda, which is a little more heavy weight. So I'll say download Miniconda. Once you install it, um, also make sure you add it to your environment variables. So let's say you're on a Windows, usually where it puts it, will put it into a directory called, let's say, Miniconda. Or if you did an Anaconda, it will have Anaconda, then scripts. So this is actually the path that you need to add to your environment variables. So when you go to the command prompt, it's able to recognize when you type the word conda, a conda command. So once you have that, next thing is clone the repository, open the, the repository directory. And the next thing is on the command line, you can go ahead and create environment to run your notebook. So I'm sure one of the questions that you're asking, okay, why do we need to do this? We all have different environments. You may have a different Python version, and all these different libraries that are dependent on this lab that we're doing or code that we're utilizing. It also depends on the Python environment, the different package versioning. Also, they also have to be compatible with each other. So to save yourself from hassle to figure out which one is compatible with another, we've created a library. So if you go to the library folder, you find environment.yaml or env.yaml file. And from there, you'll be able to call that. And that's how you're going to be able to, when you're creating the environment, you're basically telling it to follow all the steps that is specified in YAML. And also, one of the good things about the YAML file is it's also specifying the version of Python that you should also have. Once you run that, it's going to create an environment. This is the name of the environment that we're giving. The next thing to see the list of environments that you have, you can type conda info hyphen environments, and that will list all the environments that you need. To choose the environment to work with for your lab, just do a conda activate. So you activate the environment. Once you have that, you'll be able to run this in the lab. So what I'll do is I'm not going to run this command, but I can show you how you can do that. So this is a directory, the path that I utilize. Oh, I just realized I'm not sharing the screen. So let me get back to Visual Studio Code. Give me a few minutes to get there. Okay. So once you get to Visual Studio Code, you have the terminal here. You open the file. You have the file structure, that sort of thing, and you can open the notebook that you have. So the good thing about the VS Code is it does support notebooks, so you can utilize that. The next thing is being able to create an environment. So kind of like how I was mentioning, let's say you have your environment. or you have a command prompt. Hang on. Okay, it's looking kind of wonky on my screen. But to create the Conda environment is something that you have a terminal, you have a command prompt terminal within VS Code. So you can easily run that command once you open the repository and come into VS Code, open the repository, then you can go to the terminal, then be able to create your environment. It's going to take about 3 to 5 minutes to create your environment. Once your environment is created, you can type in Conda info environments to get a list of the different environments that are available. So for our case, we are utilizing Miniconda, and these are the different environments that we have. We have the base environment, and we also have the PY39 underscore EMV. So that's the environment that you just created. Once you have that environment created, you can do activate. So you can activate, like do a Conda, activate, then give it the name of the environment, and it's gonna set your environment for you to run. Another thing you can do is when you first come in here, you're gonna have, it's gonna say kernel. If you haven't selected an environment yet, one thing you can do is click on the kernel, and it'll give you, it will say Python environments. So once you click on Python environments, it will also show you the list of all the different environments that you've created. So from there, you select it. So once it's in your notebook is within that domain, you can go ahead and run the script. So everything is in the README file in the repository on how to go about and set up all of this. But with the interest of time, what I'm going to do is run the notebook. Like once you have the environment set and you have your notebook, you can click on Run All. So the use case that we're going to be utilizing is we're trying to make a prediction. So this is a classification model that we're training. And basically, we're trying to train and figure out for the diabetic patients that have visited a hospital, what is the probability? What is the likelihood of them returning, being readmitted back to the hospital within 30 days or less? So at the end of after you train your model, it's either they were readmitted within 30 days or not readmitted in 30 days. The data set that we're using is the UCI diabetic data set from like hospital data set that you can go to University of California, Irvine to be able to access the data set. So the very first thing that we're doing is not anything rocket scientist or shocker. We're just bringing in our libraries. So the first thing we do, we've already cleansed our data. So once you clone clone the repository, the good thing is you already have your test and data set cleansed. If you want to look at the data set, the training data set or the test data set, the characteristics or the features that we have in that data set is you're able to look at patients' race, you're able to look at their gender, age, where they were discharged, were they discharged at home, then how much time did they spend in the hospital, then did they have any lab work done. So you can look at all of those different data characteristics. The next thing is you're getting ready to train your model. So the first thing we do is split our data up. What are going to be the features that we're going to be using to train the model, and what is the X features, and what is your target feature that you're trying to predict. So we're splitting our data set into those features. The next thing is we need to normalize the data and encode our data. So what we're trying to figure out is, okay, out of our data, which ones are categorical data and which ones are numeric, so we can apply the necessary encoding. So we're putting all of this into a pipeline to be able to do the transformation. So once we have all of those steps, we have the pipeline that uses those pre-processing steps that we have, and the feature. In this case, we also specify the model that we're going to be utilizing to train our model. And we also have a function that differentiates which features in the data sets are categorical and numeric. And this will come later on. So doing that, we're also telling the model what is the target feature. So which column should it use as a target column. So once you have all of that, your training data and your test data and your target feature, the next thing to do is to go ahead and train your model. So then the X data set and also the target data set. Once we model, everything that we've done up to this point is what you are used to doing. So when you're training your own model, everything that, whether it's regression, classification, this is how you probably went and next, how do I get it to the dashboard? So libraries out of the open source that you need. Looks like there's a connection. Okay, I just saw a connection error. So the two libraries that you need to utilize is one is the Responsible AI dashboard. So this is the widget that deals with the UI, presenting the data in the UI. It looks like people have lost connection. Let me check.
We did lose you for about 10 seconds
me.
or so, but we're okay now, so you can carry on, I think.
Okay, good. So, so these are the libraries that you need. This one is for display purposes, and this one is for gathering insights. So you import those libraries. The next thing is, remember we had a function where you're passing in the data set. The Responsible AI dashboard needs to understand out of your data set which ones are categorical versus numerical. So we need to identify the categorical features. So that's what we're doing, extracting the features into the feature metadata container. The next thing is actually called the constructor, the dashboard. So the dashboard, in order to utilize the dashboard, you need the model that you train, the training data, the test data. Since it's a classification use case, okay, what's the target or what's the target column we're trying to predict? You tell it what type of use case you have, is it classification or regression, then pass in the features that you have. So that's that. The next thing is, remember when I was showing the PowerPoint, the different components that are going to be providing insights in the dashboard. You also need to select which ones you want to utilize to debug your model. So you can add the first one we're adding here is the explainer. We're adding it to the insights object. The next one we're going to be doing is error analysis. The next one is counterfactual, then causal analysis. Once we have that, we run the compute. So basically what the compute is doing now is, now that it has your model, your test data, it understands everything about your model, is now extracting insights based upon the different components that you have in order to display on the dashboard. So as we can see, it's still running. It's going to take a few more minutes. So once we gather those insights, one of the things, this step is not really, I mean, you can do it here, but you can also do it on the user interface. But this is if you want to declare or create different demographic that you want to zero in on and analyze. You can also create something called cohorts. So these are just subgroups of demographics that you want to do further analysis. But I included this for you to see that, yes, you can also do it programmatically, or you can also do it with the user interface. So it looks like this is still running. Let's see if, yeah, this is the thing with running things live. Sometimes it doesn't go as fast as you plan. So let me see if I can utilize the last dashboard I created. So give me a few minutes while we wait for that, and let me check if the prior run, we can do our analytics with that. So while we're waiting for this to run, does anybody have any questions? Richie, do we have questions to ask? I mean, from the audience?
There is one question from the audience so far. For anyone else, if you do have questions for Ruth, please do add them in the chat now. So the first question we had, this might be answered once you actually get to the dashboard, but Alex is asking, how do you think about accuracy thresholds?
We'll get into that based upon the demo that we'll do, because that is a really tricky question when we're thinking of thresholds for accuracy. because that can also depend on the subject matter experts, but also based upon the insights that the dashboard shows us. Let me know if you guys can see the dashboard I just shared. Okay. So at the end of the run that we're waiting for, after it runs, it shows you a localhost URL. And basically what you do is click on the URL and it launches the dashboard with insights from the data that it was able to retrieve. So this is how the dashboard is going to look like. So under error analysis, all error analysis does is for us to identify the different areas where there are issues. So remember how I mentioned that you may have a model that is 89% accurate, but realistically there are different demographics that the model is being erroneous. This is how this is like a very good way to help end users quickly identify where those issues or where the model is not performing well. So where is the model being erroneous? And the good thing is everything is color coded. So the darker the red, the higher the error rate, as we see in the decision tree. The lesser the color, we know that, or the lighter the color, we know that, okay, this is good. We don't have as much errors. Another thing the dashboard does is it will list, when it was evaluating your model, it went through all the features and lists what were the top features that it saw errors in. So all of this is to help us get to where the issues are. So the very first thing is the root node. When you click on the root node, what it reveals to us that is that for this is showing that we have a total of 500 data in our test data set. And out of those 500, it shows that 405 were correct and 93 were incorrect. So that's giving us a high-level overview. It also shows things like error rate and also the coverage. So to debug the model, the very first thing you're going to be doing is looking where the highest error rate is. So as we can see, since this one is the darkest and the fuller, what we're going to do is the dashboard gives you an opportunity to create a cohort. So you're creating a cohort that, hey, I want to investigate and figure out what is so special about this demographic that the model is not performing very well when dealing with it. So this is for patients that have had a prior hospitalization, so greater than one, and the number of lab work when they were in the hospital is greater than 20. So this is 20.5 and less than and equal to 52. So this is a group of patients. This is a demographic of patients. For some reason, the model is not doing a good job predicting. The next thing is we need to, I mean, you can create as many cohorts as you want, but another thing you may want to also do is identify where the model is not performing well, but also identify, okay, where are the areas where the model is performing really well? So what is so special about those demographic that the model is performing well? And to figure that out, you can easily hover over the nodes and it'll show you like the error rate versus the coverage. So once you compare, you can see, okay, the one with the lowest error rate, you can double click on the root node. It highlights everything. If you want to look at just one node, you can also click on that. But for this, we're gonna create a cohort out of it. So we're gonna save. And for this demographic of patients, these patients have no prior hospitalization. So the inpatient is equal or less than 0. So practically, they have not been hospitalized in the past. And the number of lab work that they've had in the past is greater than 21.5 and less than 33.5. Okay. So for the sake of time, we're just going to create those two cohorts. This one is the one that we created programmatically when we're creating when we're training our model in the notebook. That's the example I used to show you how to create it manually. By default, the dashboard always shows you all the data, a cohort of all the data. So when we train our model, basically the overall accuracy for that model was 81. So when we look at the demographic of patients at all ages and where they have hospitalization greater than 1, we can see that there are 60 people that fall in that demographic. And for some reason, the model is not performing very well. You can see that the accuracy score is 0.63. Remember the highest error rate that we had up in the tree, the dark red? That's the cohort of patients that we created. It looks like out of the 500, 51 fell in that category. And as you can see, the accuracy score is 58. So, and this is a demographic of patients that were performing very well. They're just 38, and this is how well the model is doing. So as you can see, this exposes that even no matter how you see the accuracy, there are different demographics in your data set that the model is struggling and is erroneous. And as also as you're debugging the model, for this use case, we chose a very small sample set. Also keep in mind the sample size. If it's just 5 out of 1,000 test cases, maybe it may not be so significant. So take those into account. Another thing is we're also seeing the false positive and false negatives. So we see that the model is has a very high rate of wrongfully predicting that the patients are not going to be readmitted when truly they are going to be readmitted. So there's a disparity there. The good thing is it shows other information, so you can look at the different cohorts at the bottom. What was the probability of all these groups of patients not being readmitted? This is all the data. So for the most part, between 0 and 1, for the most part, patients are the probability of them not being readmitted is high. So that's good. The one with the lowest is the one with the age group of all ages, but the hospitalization is greater than 0. So those are different ways that you can look at that. You can also change a metric and look at the opposite. Like, okay, what is the probability of all these demographics of them being readmitted? So those are the different analyses that are there for you. We saw accuracy there. So out of this groups, you can figure out the accuracy for each of the groups. But you also have other metrics that you can also look at. Now we change to look at the precision score. So you see that the precision score has even gotten worse. The accuracy score for all the data was 0.5, but as you can see, it's gotten less. And when we look at things like recall, it gets worse and worse. So this shows that, yes, just looking at accuracy scores or the aggregated performance of a model can be misleading, which leads to unreliability. You can also look at the what's it called? The confusion metrics that's available for you. Due to the interest of time, I'll quickly just show you that if you want to narrow it down to a specific feature, you can also select that and also look, okay, out of the demographic, how many fall within have these characteristics and how is the model behaving for patients that have this characteristics. You can still follow that to really figure out, okay, sometimes you may have demographic that are performing well or bad, but sometimes it's good to isolate to one feature because it could be that feature is the one that's also driving your errors or your issues. The next thing that the dashboard gives us is the data analysis. So with this, it'll show you how many out of the data set it got correct, what was the true value, what was the correct value, and also the ones that it got incorrect. You can also go to the chart. So with this one, we can look at what is the count. So look at the distribution of data before we trained anything. So we can see that, okay, for the majority of the time, the patients, most of the patients are not readmitted, and only like 100 are readmitted out of the 500. So it gives you a good idea. The next thing is, okay, what about after training? After you did your training, we see a huge disparity. So right out the gate, you see there's overrepresentation of the patients that were not readmitted versus readmitted. So this could, in most cases, pose a problem because you have imbalanced data, and it can also lead to what's it called, bias, data bias, where the model is not performing well because you don't have enough data, especially for the the patients that are not readmitted. Another thing you can do is look at sensitive features. So out of your data set, have an idea of, okay, what is the distribution of ethnicity in the diabetics patients? We see that Caucasian patients have a higher data distribution or representation next to African Americans than the rest of the other races are, or ethnicities are underrepresented. You can look at gender. So gender is another sensitive area. So that one looks pretty balanced. Let's look at age. Age is also a sensitive area. But for this one, we'll see, yes, there is an overrepresentation of patients over 60, but these are the type of use cases that sometimes we shouldn't just go by the data and panic that there is potential bias due to data underrepresentation or overrepresentation, because it could be truly in, like if you ask a health practitioner, maybe older patients with diabetes maybe have a higher representation as opposed to patients that are younger than um, 30. The next thing we can do is also look at the prediction. So let's say we look at, okay, how is the model predicting when it comes to ethnicity? It's also showing high predictions for patients that would be readmitted, but the ones not readmitted, but for the ones that are going to be readmitted is showing very low representation. So this is a prime example. Let's say this data was gathered in a demographic where maybe there's a higher Caucasian ethnicity. If you take that model to another demographic, then you're going to have issues because the model is no longer going to be reliable because it's trained to favor the overrepresented demographic. So it looks like we have 3 more minutes. So another area that you have that is good for transparency is called the feature importance. So as we're training our models, it's very important to also understand what are the features driving our model. So the good thing about the feature importance section is it goes from high to low, which features are contributing to the model's prediction. So if we look at this chart, it looks like the prior inpatient does play a role into a patient being readmitted or not being admitted. Age also plays a factor. The number of medications that they're on plays a factor. So this is also a good area to also spot potential issues. So let's say on the flip side, this is a loan approval application. And we're trying to figure out what are the key features that are driving a loan to be approved or not. Let's say the top 5 features had race, age, or gender. Those are the driving features as opposed to maybe somebody's credit or income. That's ways how we can also identify that this model is having bias. We can also do the same for individual data because it could be, let's say the model, you're being audited and we're trying to figure out for this particular patient, why that was supposed to be readmitted, but the model predicted not readmitted. Why did the model do that? So with that, you can also go down and look at what were the key driving features that made the model make a prediction for its outcome versus another outcome. And as you can see, every patient is different. and the overall global driving features that we saw is not always going to be the same as the localized driving feature, because as you see, the A1C results are the driving features for prediction for this patient. So I know we're out of time. So what I want to share with you guys is we do have an end-to-end, very detailed tutorial that you can follow. And this one goes into depth to show you exactly how to utilize the model. It's a tutorial, and you'll be able to follow and use a dashboard. There are other what's it called? There are other, hang on. Sorry about that. Yeah, there are other components that we didn't get a chance to go through. This blog series goes through all the different sections. It's an 8-part series. Same use case, and it'll show you how to debug and interpret the data, so you can apply it afterwards with your real life use case. The demo that we are showing today is in the first link. If you want to access open source Responsible AI Toolkit, here's the link. And if you just want to have a generalized high-level understanding of what the dashboard does, you can also look at the Responsible AI information. So Richie, I'm gonna hand it back to you.
Thank you, Ruth. I thought that was absolutely fascinating, just seeing how much of a difference there was in performance between those different cohorts within the data set. And very cool tools there. I hope at some point soon we get the dashboard working in Workspace. We're going to go to audience questions as a couple, but before we do that, we're running out of a bit over. If you've got to jump, then please do come back and watch the questions on the recording. In the meantime, I just want to say tomorrow we've got a webinar that provides an introduction to experiment tracking. So we've got someone from DAG's Hub coming along to talk about A/B testing and other forms of experimentation. On Thursday, we've got some people from Specsavers talking about how they use data in the optician business and how they've been using DataCamp. And then on Friday, we've got a webinar on using the ChatGPT code interpreter for data science. So we've got a packed week full of webinars. Please do go to datacamp.com/webinars and sign up for those. All right, so we'll just go through a couple of questions before we finish. So Ali asks, which kinds of models is the Responsible AI Toolkit for? Can you use it with deep learning, reinforcement learning, other kinds of model?
Okay. So for debugging the models, we do have, the one I showed you is tabular data, just regular text tabular data. Back in May, we introduced the image object detection. So if you have a deep learning image recognition model, you can also use that to make debugging. Where the product teams are working on refining more solutions. So in terms of reinforcement learning and whatnot, yeah, we don't have anything in that area.
Okay, yeah, reinforcement learning is kind of a whole different data setup. It's a bit different. So this question comes from Yolanda. I think you sort of showed that the target was imbalanced. There was sort of different amounts of data for different cohort. Maybe can you just talk a little bit about how you deal with different amounts of data in different cohorts?
Yeah. So when we look at the data, the good thing is you can look at it in all angles and just try to make sense of it. A lot of people, there's a misconception that we can just toss a whole bunch of data. the more data that you have, the more likely your model is going to be safe and not biased, but that's not correct. When we talk about imbalance, no matter how many petabytes of data, we need to understand the representation. So let's say you have a prime example is inclusivity. So there's like 1 billion people with disabilities, right? So if you have an AI system that covers the general population, what if there's a use case that you need a demographic for people with disabilities that you're not taking into account? So we're trying to figure out what is the representation. Is a certain demographic represented in your data set? If they are they also they're represented, but it's very few, which is going to lead to bias, or do you just have one demographic that is overrepresented, that when you put it out in production, you're all going to run into issues? So that's where what we're talking about, data imbalance.
All right, super. Thank you for that. We are running over, so I'm going to call time at this point. Thank you once again, Ruth. It was really informative. Lots of issues to think about here in terms of how you go about making sure that your models are performing fairly. So thank you to you again, Ruth. Thank you to Reese for moderating. Thank you to everyone who asked a question. Thank you to everyone who showed up today. And I hope to see you again in the webinars later in this week. All right.
Yeah,
Bye,
and
everyone.
thanks, Richie, for having me. This was fun.